start recording here. Okay. So, let's stay up here for just a second, but did anyone not get a term schedule? Looks like this. Yeah, I did it. I kind of did them as people are coming. Anyone else need one? No, everyone else has one? Great. So I do these term schedules. It kind of has everything that you need instead of the course outlines. So it has my contact information. It has the test dates. So you can put those in your phone. Now, maybe, I don't know. And then what we're going to be doing kind of day by day. And one thing to keep in mind, those review days before the tests, right? That's where you're going to show me that you did the practice test for a completion mark as an assignment. You don't want to miss those because those are kind of easy marks, right? And so I'll talk more about that closer to test one, but I can't remember if we actually talked about the grade breakdown last day. I'm not sure we did. So 15% for assignments. Most of those are Moodle quizzes. I like to do just kind of 5-question Moodle quizzes, kind of keep you on top of things, right? So, but there will be quite a number of them, okay? And then we've got test one. Test one worth 10%, because it's kind of like, are we all on the same page? Great, moving on. Test two worth a little bit more, 15%, and then test three worth a little bit more, 20%, right? Just kind of building up momentum for the final exam, which will be the 40%. So that's going to be our grade breakdown. Okay. And we actually end up with 1 or even 2 more days than I had last term, so I wasn't really sure what to do with that. So often I'll leave, so looking at the last couple of weeks, chapter 8 is really only one section on mortgages. So what I've decided to do is I'm squeezing mortgages into test 3. What's nice about that is you'll have been tested on everything that'll be on the final. Okay? So that's nice. You've kind of seen it in a test, and then we just have 3 days of review for the final after that. So that's pretty good. With that kind of luxury movement, I figured, yeah, let's move 8.1 onto test 3, kind of see how it goes. And then we can have lots of review days. I did squeeze April 8th and 10th on the same line. As you can tell, I was running out of room. I didn't want to print it on a separate sheet. Okay? But I think it's a pretty handy little sheet, right? And you can keep track of what we're doing. I will try to stick to it as much as I can. Right? Should be pretty good. Should be pretty fine-tuned by now. But yeah, you know how things go. So, uh-oh. Kicked me out. And ding. Okay. So the first thing that I want to do is, I think you guys have some new calculators potentially, right? So even if you forgot to get your calculator, I know you will get one. But for those of you that did get it, let's just take a couple of minutes to set it up because by default, I think it only gives you 2 decimal places, for example, right? And so let's change that. So what I'm going to do here is kind of change things this way. How's that? It's not great. Whatever. Okay. It's great on here, not on here though. Okay. So to change the number of decimal places, there's two things that we're going to do. Just the basic setup of these calculators. Once we've done it, you don't have to do it again, right? First thing we're going to do is change the number of decimal places, which is in the format. So over the decimal point, it says format. So you're going to go second, right, to access the second menu. So second format. Okay. And by default, it says decimals equals 2. Okay. So it probably looks something like this, right? So I'm going to change that to 9. Okay. One thing to keep in mind, so it doesn't say decimals. I keep trying to focus on my calculator. It's okay. Unless it says decimals equals whatever, you haven't actually saved anything, right? So you have to hit the enter button, and this will kind of come up kind of a lot when we're using the calculator. So in order to store something, we have to hit the enter button. Okay. But when we do, then it says decimals equals 9. Okay. So from here, you're gonna scroll down, I know, using the down button. Okay. So you're gonna click down, 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 down. So past degree, past US, whatever, I don't even know what that is. Past US, whatever. And then it might say CHN, right, by default. So that just takes all your, whatever you enter, it just does whatever you tell it to in order. Okay. We're going to change it to say AOS, which is just, okay, follow bed mass, essentially. Okay. So to change it, I think we go second enter. It is trial and error. So second enter, and you can flip back and forth between the two. I'm really not sure when you would want it to be. Oh. CHN, we always want it to be AOS. Okay. But now that you've said it, you don't have to change it ever again. So you'll likely forget, and that's okay. Okay. So make sure you have 9 decimal places, right? So one way to check. So remember to get here, we were in the format menu, right? Which is kind of like a second menu. So to get out of a second menu, any second menu, you're going to go second quit. And that kind of bumps you out of that second menu. Okay. So now to try it, to make sure that you have 9 decimal places, try something like 1 divided by 3, and you should have all 9 decimal places. Cool. Okay. So if it doesn't seem to be working, then just come see me after class. But otherwise, we're okay. Cool. Any questions about that one? No. I guess that'll also be fuzzy as it was in the video as well. In the beginning, how nice. Okay. That's what I needed that. As promised, I'll sit down because we've got a lot of writing to do today. Okay. So, down here in the pit, feels so tiny. Hey guys. So, okay, just we didn't really do anything substantial last day, right? But we did talk about order of operations and did kind of a refresher on legal math, right? What are we allowed to do? What are we not allowed to do? Okay. So we basically just talked about bed mass Order of operations. Okay. I need you to make sure that you can do all of the all the suggested exercises for 1.2. Okay. If you're having a hard time there, then we need to deal with that right away. Right. So then you need to come see me and we need to work through those. Okay. So make sure you can do all the suggested exercises for 1.2, which in my book is on page 16. I think I have the most current edition. Who knows? Really? I'm assuming. Okay. So just make sure that you can do all those. We'll work on that stuff, you know, kind of implicitly throughout the course, right? So we'll need all those tools. All right. Any questions about last day before we get started on this new stuff? Hey, that wasn't much of a review. Bed mass? That's it. I know. Well, like I said, we didn't do much. All right. So 1.3 takes us into rational numbers. So rational numbers are really just fractions, right? A divided by B, that kind of thing. So rational numbers. Make sure I'm recording. I had a scare earlier today where I forgot to record, but only for the first 2 minutes. So wasn't that big of a deal. But you guys can help me out. If it says, well, it's kind of cut off. If it says record up there, then I'm recording. But if it doesn't, then I'm not, and that's a problem. Question? No? Oh, awesome. Good. Thank you. All right. So rational numbers, also known as fractions. And remember, we talked about fractions last day, but a fraction is a numerator over a denominator. And I kind of bring that up again because I need you to be fluent with that terminology, right? Because I'll say, oh, the numerator this, the denominator this. And I used to have a heck of a time remembering which one is which. And asked me if I did my undergrad in math. Yes, I absolutely did. And I still had a hard time. It's like numerator. So finally, I just decided, okay, numerator, numero uno, it's on top. That's all I need to know. Denominator's on the bottom. Right. So whatever you got to do to remember these things is good. So fractions, we can do all the same things that we can do with any other number, right? Or any other equation. We can multiply, we can divide, we can add, we can subtract fractions, right? But there's rules around all that. And so I'm gonna change the order a little bit from the textbook. The textbook, of course, starts with adding and subtracting fractions, which is actually a little bit harder. So I want to leave it for after multiplying, dividing, because that's easy. Okay. So multiplying fractions, we'll start there. To multiply two fractions, you're just going to multiply across, meaning you're going to multiply the two numerators and you're going to multiply the two denominators to get one fraction. Okay. So to multiply two fractions,
multiply, and I'll put in quotes, across, right? So multiply numerators together, and multiply denominators together. To form a single fraction. So in math, we like to do math with variables. We don't like to stick to hard numbers. So if you have something like A over B times C over D, right? What I'm saying is you would multiply A times C, right, to get one number. So that would be AC. And then multiply B times D to get BD in the denominator. Which would just be a single number. For example, let's have a look at example 16. If you have 38 over 55 times 15 over 2, multiplication's nice. We just multiply across, right? So that's going to be 38 times 15. Let's clean that up a bit. Divided by 55 times 2. I'm kind of sneaking it in there, right? But I like to use brackets if I'm multiplying two things, right? You could use an X or you could use a dot if you want to. I like brackets. So 38 times 15, 570, over 55 times 2, 110. And then remember my pet peeve from last day, right? I like my equal signs stacked. So I don't want to see things moving across the page for more than one equal sign, right? If you've done an equal sign, you put it down below. That's just me being bossy, picky, right? But it's proper. Okay. So any questions about multiplying fractions? Let's get to dividing fractions then. Kick it up just a little notch. Okay. So dividing fractions. So we've got a fraction, well, I guess just 2, right? Divided by another fraction. Right? So now we've got kind of 3 fractions all in one, right? And so what we do, well, try to turn it in your way, is we take the denominator and we flip it, and that kind of brings it out here, right? And then we can multiply those. Okay? And so, and then we've essentially just divided these fractions. Okay? So to divide 2 fractions, we need to, I'll put in quotes, flip. Oops. Flip the denominator. Then we can multiply the flipped denominator by, oh, this is flipped, the numerator. So just with letters, right, if we have A over B divided by C over D, it's a bit of a mess, right? But what we said was, okay, we're going to take this denominator and flip it, and that brings it up to the same level as the numerator, and then we can just multiply across. There's a couple of different ways that you can do it, but I find that this is the easiest way to do it. So flip it, multiply, done. So this becomes A over B times D over C, right? And now we're back to multiplying fractions, which we know just yields AD over BC. Let's do an example. Example, I don't know if there's a number. 17. If we've got something like 18 over 5 divided by 27 over 15, I actually prefer to write one over the other, right? Like I did with the variables, right? So I'm going to rewrite this as 18 over 5 divided by 27 over 15. Because now it's easier for me, at least, to see that, okay, the denominator, I'm just going to flip it, and then I can multiply it by 18 over 5. So this becomes 18 over 5 times 15 over 27. Which, for multiplying, right, 18 times 15 over 5 times 27 yields 270 over 135, which is 2. And just use your calculator for that stuff, right? If 270 over 135 didn't yield a nice number like 2, feel free to leave it like this. I really hate simplifying fractions, so I'm not going to make you do it. It's really time consuming, and we have calculators, so I guess it's a skill on its own, but maybe I don't have it. And that's okay. So, but always check. If you get a nice number, then it's nice to just give the nice whole number. Okay. Let's do another example. It's a little bit different. Example 19. What if I asked you to solve for x? If you have something like 45 over 21 equals x over 77. Couple of ways we can imagine doing this, right? One way is just to imagine pulling out the x. This is technically, so x divided by 77 is the same as 1 over 77 times x, right? And so if we just kind of separate these, right, then we know that 1 over 77 is multiplying the x, right? So shake the x loose, right? To do that, we have to divide both sides by 1 over 77, right, in theory. Or if you just said, okay, well, to move this over, I have to multiply by 77, that's great. But in theory, what we have been doing, and technically what you are doing, is you're saying, okay, well, that's the same as 1 over 77 times x, right? That's the same. Because if you multiply 1 by x, right, technically x is x over 1. So now you've got two fractions. You've made two fractions out of one fraction. Yikes, right? Works both ways. Okay. And so now x is being multiplied by 1 over 77, right? To undo multiplication, we have to divide, right? So really what we have, right, is we've got, I'll just copy down 45 over 21 here. So then we need to divide both sides by 1 over 77. Okay. So divide both sides by 1 over 77. Right. Technically, which would cancel these guys. But now we're left dividing a fraction by a fraction, which we know how to do, right? So this becomes 45 over 21 times 77 over 1, right? We have to flip the 1 over 77, flip it, and multiply it, right? Equals x. And then you have 45 times 77 is 3,465 over 2 times 1, which is, or 21 times 1, sorry, is 21. It's x. And then I always do kind of whenever, or as soon as I can, I move my x over to the left-hand side. And there's no kind of rhyme or reason, except I like to have whatever I'm solving for on the left-hand side and whatever else on the right-hand side. Okay. So here I'm going to pull that move. X equals 165. Okay. Of course, if you look at this, right, this original one, and you say, oh, well, I'm dividing x by 77, so to undo that, I just need to multiply this side by 77. That's right, right? You are doing this, right? You're multiplying by 77 over 1, but you just kind of skipped a few steps to get there, right? So however you do it in your mind, it's good, right? So if you looked at this and said, oh, I need to bring the 77 over here, that's great. Or if you need to say, okay, well, x is multiplied by 1 over 77. I know how to deal with fractions. I can go from there. Something tells me, though, most of you probably looked at this and said, I'm just going to multiply by 77. Right? But here's the reason you did that. So whichever way you like works. Okay. Any questions about that one? Okay. So let's see if I had made a note. No. So now let's talk about adding and subtracting fractions. Like I said, the textbook goes through adding and subtracting first, but it's a little bit trickier than multiplying and dividing. So I kind of wanted to get you warmed up first, and then we can go into adding and subtracting. So adding and subtracting fractions. The hiccup with adding and subtracting is that in order to add or subtract 2 or more fractions, we have to have the same denominator, right? So before we can do anything, we have to get them to have the same denominator. So adding or subtracting, enjoy, is the pop machine. Adding or subtracting two or more fractions can only be done if they have the same denominator. If they have the same denominator. So we need to find a common denominator which you've probably heard of, right? Common denominator. Again, there's lots of ways that you can do this. I find that the easiest and the safest way to do it is if you have two fractions that you have to add or subtract, right? Then to get a common denominator, right, you look at the denominator of one, look at the denominator of the other, and then just multiply those two denominators, and that's a common denominator, right? You took these denominators and you smushed them all into one number, right, by multiplying them, right? And then they're common denominators, right? And so that's not the most, I don't know, beautiful way to do it, but it's the safest way to do it. Okay? So the textbook goes through fancier ways to do it, find the least common denominators, but I just want a common denominator. Okay? So the safest way to find a common denominator, is to multiply the two denominators together. The two denominators together. Let me just pull up an example. Example 15, just so we have some numbers to look at. If we have 15 over 22 plus 1 over 2, like I said, there are fancier ways to do it, but the safest common denominator here, right? The denominator here is 22, and the denominator here is 2. So a common denominator would be 22 times 2, right? 44 divides by 22. 44 divides by 2. Safe, right? Of course, 2 goes into 22. It's not always that nice, right? But so I'm just showing you the safest way. Okay? So you're going to take this times this. That's going to be your common denominator. Okay? So make a little note here. Denominator number 1. Denominator number 2. So our common denominator must be 22 times 2. Yeah. So that's what we want to have on the bottom, right? But we can't just change this 22 to 44, call it a day, right? We also have to alter the numerator, right? So whatever we multiplied 22 by, right, which is going to be this little guy, we have to multiply the numerator by as well. Right? Same thing on this side, whatever we multiply 2 by, which is going to be the 22, we also have to multiply the 1 by. Right? And so in effect, we're multiplying each of these by 1, right? Here, we're multiplying by 2 over 2, right? And over here, we have to multiply by 22 over 22. 22 over 22, there. Okay. And so, once we have a common denominator, or once we know our common denominator, I should say. Once we know our common denominator, we need to multiply each numerator by the same value as its denominator. We need to multiply each numerator by the same value as its denominator. All right. So kind of play by play, we had 15 over 22 plus 1 over 2. Right. Kind of in different color, hopefully. Right. Showing up slightly different color. What if I go pink? It's all the same-ish. It's a different color. So then, right, we have to multiply 22 by 2. That's what we decided was our common denominator, right? So we've got times 2 over here, right? But we can't just multiply the bottom by 2 and leave the top hanging. So we have to do 2 over 2, right? Same thing on the other side here, right? 2, we have to multiply by 22 to get to that common denominator, right? And so we've got 22 over here, but we can't change the bottom without changing the top, and so 22 over 22. Notice, right, that both of these, right, we're essentially just multiplying by 1, right? So that's a pretty common trick that we use in math, is we say, oh, well, if I just multiply by 1, right, we know 2 times 1, 3 times 1 is just 2, 3, right? Nothing changes multiplying it by 1, right? So that's nice. That's a nice property to have, right? And so we have 2 over 2, nothing's really changing, right? 22 over 22, nothing's really changing, right? But because we're multiplying these fractions, now we have the same denominator for both of these, right? And so we get we have 15 times 2, right? Because math still applies, right? We'll leave the fractions alone, but we're multiplying these fractions before we can add them, right? Also, we have to get the common denominator. That's the whole name of the game here. So 15 times 2, let's call it 30. 30 over 44. Okay. Plus 1 times 22 is 22 over 2 times 22 is 44. Okay. Now we finally have this common denominator, right? And so now what we do is we just add the numerators together, and the common denominator just kind of merges into 1, right? So our answer will still be over 44, right? We're only adding the numerators. So once we have written our fractions with common denominators, we can add or subtract. Works the same for adding and subtracting. We can add or subtract the numerator. So from 30 over 44 plus 22 over 44, that's the same as 30 plus 22 over 44. $52 over 44. I would probably just leave it there. Seems I did too. Okay. You can use your calculator if you want, but 52 over 44, that's the answer. Okay. Any questions about that one? So subtraction works the exact same way. Hard part is finding that common denominator, right? After that, you can just add or subtract the numerators, figure it out. Ooh. All right. 1, 2, 3. Okay. Let's do 1.4 then. So 1.4 is on expanding and factoring, right? So like I said last day, we're just kind of spending some time working through math rules before we get into actual math, right? So expanding and factoring, no surprise that we're covering it. So in terms of what is expanding? Expanding is when we have kind of a compact equation and we want to expand it, basically getting rid of all the brackets, right? Or trying to get rid of brackets. Okay. So for example, if you have something like, A times B plus C, right? We do A times B, so AB plus AC, right? That's expanding. Or just as a quick example, if we have 4 times A plus 3, right? To get rid of these brackets, because 4 is multiplying both A plus 3, right? Both of those things. And so we get 4A plus 4 times 3 which is 4a plus 12. So I think expanding is really fun. I kind of like to expand huge things because it's really satisfying. You just kind of, right? Tedious, but fun. Factoring, not so much. Factoring is just expanding in reverse, right? Where we're trying to condense an equation. It's not my strong suit because it's kind of tricky. You have to find common multiples that you can pull out, right? And so factoring is basically expanding in reverse. Right. So if I gave you something like 4a plus 12, and I asked you to factor that, well, I wouldn't, but just for fun, right? You would see if there were any common multiples in here, right? 4 and a, right? And 12, well, I know 12 can be divided by 4, so that means I can pull out a common multiple of 4, right? So now I can pull out that common multiple of 4 outside the brackets. Right? And then 4 times a makes 4a plus 3. 4 times 3 is 12. Right? So you always kind of want to make sure that you can get back to where you started when you're factoring. Okay. So I'll just make a note here, right? We pull out the highest common multiple. The highest common multiple So what if we had something like, if I asked you to factor P plus PRT? Kind of weird, but we've got variables, that's okay, right? First one just has a P in it, so hopefully we can find a common multiple of P. Phew, we can. Right, and so dealing with variables is actually easier, right? Because you can spot these P's, RT's right away. Right? So we can pull out a common P. We don't want to leave this P alone, right? P is technically multiplying 1, right? So when we pull out that common P outside the brackets, then we've got a 1 left in here. P times 1 to get that back. Otherwise, we lose it. Right? So it's P times 1 plus RT. Yeah. So you don't want to forget that 1. Okay. And I encourage you to expand to check, right? Take P times 1 plus RT. And P times 1 is P, and plus P times R times T, right? Which is what we started with here, right? So we did it, right? If we got back and didn't get the same thing, then something happened in there, right? So whenever I have factored anything, I like to expand to make sure I get back to where I started. To make sure I get back to where I started. Hopefully you'll enjoy doing the same. Maybe it's because I like expanding. Who knows? But it is a good idea to check it. So, any questions before we do an example? So example 21 asks us to factor 3b plus ab plus 1 plus t times b. Got it. Okay. So first glance, right, the only common multiple that I can see is just the b, right? We've got a b in each of these terms, right? And so I'll throw that on here, right? Each of these kind of clusters is a term. And I see B, B, and B. We factor out the B as it is the only common multiple. So we factor out the B as it is the only common multiple. So we'll just kind of extract the B's, right? And inside the brackets, we'll have everything that's being multiplied by B. I guess a skeleton of sorts. So I'll just rewrite what we're trying to factor first. Right? So we have a clean slate here, 3b plus ab plus, and then in brackets, 1 plus t times b. It might be tempting, right, to expand those brackets, the 1 plus t, which you can, right? But because I'm about to pull out the b, right? I'm just gonna leave the 1 plus t in brackets. It doesn't matter, right? It doesn't change anything, but I'll just leave it alone, save myself some work. So we've got b on the outside, and then inside the brackets, we have everything that's being multiplied by b, right? So we have first 3 plus a plus 1 plus t. Notice now that these brackets over here, they're not doing anything, right? The 1 plus t in brackets, we're just adding all along here. Brackets only matter if we're multiplying or dividing, right? And so we've got 1 plus t here, but really we can just expand it and say 3 plus a plus 1 plus t, right? It's all the same. So, or this is the same as b times 3 plus a plus 1 plus t. Which we can simplify even more, right? We can add the 3 and the 1. So this equals b times 4 plus a plus t. Right. Now, remember, when we're factoring, right, I encourage you to expand to check it, right? Make sure you get back to where you started. As you might suspect, we're not quite going to get back to where we started, right? But we can work with that. So expand to check, right? So then b times 4 plus a plus t becomes, well, I guess technically b times 4 plus b times a, but I don't know, for some reason, I like to have the b's after. Right? Since we're multiplying inside the terms, it doesn't matter which order we write them in, right? So whichever way you prefer, I like to have 4b plus ab plus gb. Doesn't matter. Uh-oh. What's an alarming color? Orange. Does it show up? Oh, doesn't it? Does. Doesn't look like 3b plus ab plus 1 plus t times b. That's a face. Oh my goodness. But if we take 3b plus ab plus 1 plus t times b, and we expand the brackets in here, right? Then we've got 3b plus ab plus 1b. I'm not going to write the 1 though. B plus, and then t times b, tb. Phew, it's looking better already, right? Because now we've got common multiples, right? Or like terms, I should say. 3b and b can be added together. So collect like terms, and we get 4b plus ab plus tb. Phew. Now they're the same. All right. I know you guys were worried that they wouldn't be the same. It's just an exercise in, I don't know, molding equations, right, to where we need them to be. It's not something that I'll test you on or anything. Oh, great, now you tell me. Yeah. So that's factoring, right? We looked at a simple case of expanding, right? A times b plus c. We just pull the a inside. That was easy. But what if we have to expand something like, so what if we have to expand something like a plus b times c plus d? Gets a little messier. Or even bigger if you want. See if I care. We have two options for dealing with these, right? Both equally good, both equally correct. It's whichever one you feel more comfortable using. go ahead and use that one. I'll introduce both. We have two options. The first one, I'm not sure it has a name. The second one has the name FOIL. First, outside, inside, last. I know that's the name. Still, well, it makes sense, but I just do it. Anyways, so the first option is if you have something like A plus B times C plus D, well then, just imagine this first term as one thing, right? And then just do what we were doing earlier, right? Take this times this, that's the first term, and then this times this, that's the second term, right? And now you actually have one term times bracketed terms, right? And then you can expand that further. So it would look something like A plus B times C plus A plus B times D. Trying to squeeze it in there. Which then, if we bring the C inside those brackets and expand those brackets, then we have AC plus BC plus AD plus BD. Oy. Gets a little out of hand. So that's our first option. Notice all the brackets are gone now, so we're done. We expanded it. The second option is FOIL. So FOIL, I'll leave some room here. We've got A plus B times C plus D. I'll use a different color. Not that it looks any different on there. Okay. But so you take this term, multiply it by this one, right? And then take this term again, multiply it by this guy. Then take this term, multiply it by this guy, this term, multiply it by the last term, right? And so we kind of get this whoop, 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 whoop. Okay, no takers. Whoop, 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 whoop. Right. Can't remember what term it was that I was teaching this, and I just kind of do it. I didn't know it had a name, FOIL. So I just kind of did it, and everyone's like, do you mean foil? And I was like, I don't know. I don't know if that's what I mean. Foil. That's what I mean. So what does this look like? Well, looks the same as before, right? Option number one, right? But we just kind of get there a little bit faster, just a smidge faster. Right? So we do A times C plus A times D plus B, times C plus B times D. Right. So, which if we rearrange the terms, they're the same. So equally good options. Any questions before we do an example? Example 23. Expand and simplify. What? We simplified last day. Now we're going to expand, and then we're going to simplify. Great. I'll write it way over here on the left so that I've got lots of room on the right. So I'll do x plus y times 3x plus y. So whichever way you want to expand this is fine, right? You can use the x plus y as just a single term multiplied by 3x, right? And then multiply it by y, and then expand those individually, right? But I'm going to keep using the FOIL technique, I guess. So that means that I've got x times 3x. Actually, I'll put brackets around like I happen to. Plus x times y. Plus, and now moving on to the y's, right? Y times 3x plus y times y. They don't go through it in the textbook. Probably just assumes that you know it, but in case you don't quite remember, if we have something like x times x, right, to multiply those together, you're going to add the powers, right? So x on its own is just x to the power of 1, right? So x times x is what? X squared, right? Because you get x to the power of 1 times x to the power of 1, you add those powers, then you're in. Yeah? So in general, we have x to the power of a times x to the power of b, right? Just using letters. We've got, that's going to be x to the power of a plus b. That's in general. It assumes that we have the same base, right? The base being x. And we actually talk more about how we deal with powers later in the chapter. So it's kind of funny that we need it now and then we discuss it later. But that's as much as we'll need for now. And then we'll keep talking about powers later on. Okay. But so for things like x times x and y times y in that last term, right, they just become x squared and y squared. Okay. So x to the power of 1 times x to the power of 1 makes x squared. Okay. So what we have, right, going back to our expand and simplify question, right, we've got x times 3x, that's 3 times x, right? We can move those around. If we're multiplying, we can move things around as much as we want, right? So we've got 3x squared. X times y is just xy, so plus xy. And then, right, personal hang-ups, I like to have the coefficient out front, so I'm gonna move the 3 to the front, and then I like to have some kind of order that I follow with my variables, right? So I'm going to keep writing them as x times y, right? So I'm going to reorder them to be x times y. So this is going to become 3xy, right? But you'll notice that they're the same. And then plus y squared. Yeah. We had to expand and simplify, right? Which means that as a kind of once over, we need to look for common multiples, right? So common multiples, we look for Are there any other x squareds? No. Right. Are there any other xy's? Yes. Right here. And then are there any other y squareds? No, there are not. Right. But we can collect these like terms. Right. xy plus 3xy is 4xy. Right? Because we just work with those coefficients. As long as we have like terms, then we can just deal with the coefficients. So we've got 3x squared plus 4xy plus y squared. And I'll just highlight that these are like terms. So we just collected like terms. Okay. Any questions about that one? Great. How about example 24? Expand and simplify again. X minus 2 times 2x squared minus 3x minus 4. A little bit bigger. So I'll give you just a minute to work through that on your own. Just give it a go. Careful with these negatives now though, right? Those have to stick around. We can't lose them. Okay. Might still be working on it, but we'll just get started here. So it's really kind of just a plug and chug kind of thing, right? So we're just gonna plug away, expand, and see where we get to, and then try to find some like terms, collect them, simplify, and we're done. So we've got x times 2x squared. And then we have minus 3x, right? So we have to keep that minus 3x. And there's two ways that you can do it. You can say minus 3x squared or 3x times x, right? Move the x to the other side if you want to. Or another thing that you could do is you could say, well, that's the same as plus x times negative 3x. Or you can just look at it and say, well, that's the same as minus 3x squared. Right. All of these are the same. So whichever one comes naturally to you, then that's good. Right. So I think I'll go with the minus 3x squared. Saves me some trouble. Or maybe I'll keep, it's too much work. I'll keep the minus 3x times x. How about? Doesn't matter. Moving on. So same thing for the minus 4, right? But that's what I mean by keeping these negatives, right? We have to keep them around. Okay. So minus 4 times x. Quickly ran out of room here. Moving on to the 2, right? The minus 2. So minus 2 times 2x squared, and then minus 2 times minus 3x, minus 2 times minus 4. Hopefully I didn't forget anything. 1, 2, 3, 4, 5, 6. Good. Oh. Things got kind of crazy here. I'm going to move my equal sign over. 2x squared times x. Now we've got x to the power of 2 times x to the power of 1, right? So combining those powers, we get x to the power of 3. So we get 2x to the power of 3 minus 3x squared minus 4x minus, now I'm here at the minus 2 times 2x squared, right? That's just minus 4x squared minus 4x squared, and minus 2 times negative 3x, right? That's actually going to turn into a positive, right? So we have to keep track of that as well. So minus negative 2 times negative 3 is positive 6. So plus 6x. And then same thing for negative 2 times negative 4. Plus 8. From here, we can collect like terms, right? So again, we're just going to go through, I don't know, from left to right and say, okay, well, are there any x to the power of 3s in here? No, just the 1, right? Are there any x squareds in here? Yes, there are. Are there any x's in here? Yes, there are. And then 8 is just on its own. That got kind of ugly, but you can group them if you want to. So this, writing my like terms just in their own brackets, just to keep them together. Collect like terms. We get 2x to the power of 3. And then I'll just do plus and then minus 3x squared minus 4x squared. And then plus minus 4x plus 6x, and then plus 8. Right. So see what I mean by just kind of grouping my like terms inside these brackets so I can see them clearly, right? And I just default to writing a plus, and then the negatives just stay inside the brackets, right? Otherwise, I would have to pull out a common negative. It gets kind of messy. So I just put a plus in front and then everything in brackets, then I don't have to deal with it. But now inside these brackets, now I just have to deal with the coefficients, right? Simplify those, and then I'm done. So I get 2x to the power of 3 plus negative 3x squared minus 4x squared puts us at negative 7x squared plus negative 4x plus 6x is 2x, and then plus 8. We don't need these brackets anymore, right? So we'll just say 2x to the power of 3 minus 7x squared, right? Adding a negative is just subtracting. It's the definition of subtracting, actually, adding a negative. Plus 2x plus 8. Nice. Any questions about that one? Yes. How about 2 steps? Sold. Yeah. So I would want to see something where you've expanded it and then something where you've simplified it. That's good. Then I'm happy. A lot of the time I'll show more work than I'll require of you on a test, for example, right? But that's just because I'm trying to teach you things here, so I'm trying to show you all the steps. But if you're ever not sure if you're showing enough work, then you can just ask and we'll go through it. Okay, good. Let's do another example. Example 26 just asks to simplify. We've got 3y over 1 plus 0.06. Is it 0.06? Or 0.06 over 1? Did I add that after or? Oh yeah. 1 plus, steal it here. 0.06 times 175 over 365. So we have to simplify this. Right? There's a lot going on. We've got a fraction and then another fraction. We've got multiplication, we've got addition. Right? And so for any fraction that we have, right, we're going to deal with the numerator and the denominator separately, right, until they're as small as they can be, right, until they're as simplified as they can be, then we start working with them. Right? And so it doesn't matter which order you do them in, right? You can even do them simultaneously, right? Simplify the numerator, simplify the denominator, work through them at the same time, right? 3y, there's nothing that we have to do there, right? So we can just write it as 3y. There is some work to do in the denominator, right? So we use BEDMAS, right? We've got multiplication, we've got the fraction in there. So it really doesn't matter which order we multiply or divide in. But let's just multiply for fun. Right? So multiply 175 over 365 times 0.06. So we get 1 plus, well, technically, we can rewrite 0.06 as 0.06 over 1 times 175 over 365. That's just showing off our fraction skills from earlier today. Right? So, no big deal. 3y over 1 plus, and now we can just multiply across, right? Because we're multiplying 2 fractions, right? 0.06 over 1 is a fraction. It's just 0.06 though. And so we get 0.06, oops, 0.06 times 175 makes 10.5. Divided by 365. Right, 1 times 365. So divide that by 365. So we have it. Okay. Did you guys hear that? There's money falling on the floor. So we get 3y over 1 plus 10.5 over 365 is 0.028767123. Remember what what we talked about last day, right? I don't want you to be rounding any numbers, right? The only numbers that you're allowed to round, and you have to round to 2 decimal places, is money, right? Money we have to round to 2 decimal places. Otherwise, we keep all our decimal places, or as many as we can. Now that you have your fancy calculators, I'll show you guys again, but you can store this value by using the store button. You obviously can't see my, right, but the STO button is on the left-hand side, kind of above the clear button, or 2 above. So if you hit store, and then it wants to know, well, where do you want to store this number? If you hit store in 1, nothing happens. It's okay. You can clear it. Safe. And then hit recall, so the RCL button. Recall 1. Ta-da! Nice. So that'll come in handy, right? Not having to plug in all these numbers all the time, right? So now you can store these bigger numbers, and there's no need to round any numbers at all, right? And so now we can keep going, right? We can simplify the denominator by just adding 1 to it, to this 0.028767123. 3y over 1.028767123. So plus 1. And then you've got options. You can store this again. Right? You can even store it in 1 if you want. It'll just overwrite whatever new values you store in there. Right? So store this in 1. Because remember, the goal was to simplify this, right? So 3y over 1.02876 is not quite simplified, right? We can simplify 3 over 1.028 whatever to one number. So let's do that. So that's the same as just rewriting this, right? 3y is 3 times y. So we can split up the numbers and the variables and just have them separate. So we get 3 over 1.028767123 times y. That's the same. Right? Multiplying fractions tells us so. So 3 divided by 1.028767123. You've stored it. That's nice. We have 2.916111851y. We did it. Nice. I do want to make a note, right? Because what we were doing over here, just make a quick note. So we simplify the numerator and the denominator independently until the final simplification. The numerator and the denominator independently until the grand finale. No, until the final simplification. Nice. So, any questions? No? Again, I'll assign some, I guess, optional homework. Where are we here? I want you to do, or make sure that you can do all of the suggested exercises from 1.4. So make sure you can do all the suggested exercises. Oh, what's going on here? Do all the suggested exercises from 1.4 on page, well, in my book, 22. But like I said, it's okay if you got an older edition or maybe even a new edition or newer edition potentially. I don't think it's changed much. So just make sure you work through those. They won't take very long. There's only about this many, right? Just gonna make sure that you're able to do those. And then I guess I don't see you till Monday. Weird. Have a good weekend. Feels weird. But I'll see you on Monday. All right. Oh, and if you wanted to stick around and work through those problems, then I'll be here. But you don't have to. By no means, you don't have to.